Hello everyone, and welcome to another episode of BMED 202. In this episode, you will be shown how to deal with uniformly distributed loads in a simply supported beam. Now, what is a uniformly distributed load, or for short, a UDL or UDL load? Okay, this is a load that is, rather than acting at a specific point, like a point load, it is acting at a section or a section throughout the beam. So if you look at the diagram right now, you will realize that you're seeing 2 point loads and 1 UDL load. The point loads, or the unit for the point load, is kilonewton, while the unit for the UDL load is kilonewton per meter. This is due to the fact that the point load is acting at a singular point, while the UDL load is acting at various points. It is acting at a section or throughout a section of the beam. Now, if you look, you will realize that the span of the UDL load is 3 meters. So point loads don't have a span, but UDL loads have a span. And all that this is saying, for every meter that the load is spanning, the UDL is acting or reproducing or exerting a certain amount of force. So for this specific UDL load, we are seeing 4 kilonewtons per meter. Please note, this is not Newton meters, this is not moments, this is the notation for a UDL load. So it's kilonewtons divided by meters. And all that this is saying for this particular UDL is that for every meter distance, there's a 4 kilonewton force acting on the beam. So since this UDL load spans 3 kilonewtons, you're basically having a load of 12 kilonewtons acting on the beam, right? So all you have to do is to convert this UDL load into a point load in order to work the equation and solve for simply supported beam reaction forces. So if we are supposed to find R1 and R2 for this scenario, we cannot do it as is. We have to firstly calculate the respective point load that is acting on the beam, meaning we have to convert this UDL load into a point load. And this is how it is done. All you are going to do is multiply the UDL load by the span that the UDL load takes up. So this UDL load is 4 kilonewtons per meter, and the span is 3 meters. So when you multiply 4 kilonewtons per meter by 3 meters, you'll arrive at 12 kilonewtons. And as you will realize, once you're multiplying the unit, the meters, -1 will be cancelled out by the meters. So the answer will be 12. Now you will have to find out the center of that point load. And in order to find out where that point load is acting, all you have to do is divide the 3 by 2. So you will now have 1.4 on either side. So let me show you what is happening here. So from this point to this point is 3 meters. So the point load will be acting in the middle. So it will be 1.5 from here and 1.5 from here. So the point load conversion, it will be acting 1.5 from this 5 kilonewton force, and it will be acting 1.5 plus 2 from this 4 kilonewton force. So let's show you how that will look. So you will now have this to work with. So this is the diagram that you will use only for the sake of calculating the R1 and the R2 forces. UDL loads are treated as point loads when calculating the R1 and R2 forces, but it is treated as a UDL load when doing other calculations such as the shear force and bending moment diagrams. So let's proceed and show you how this will work out. And I'll use R1 as the point of rotation. And as you may see in the previous videos, I've already explained how this is supposed to be done. This time around we have 3 clockwise moments and 1 anti-clockwise moment, and all of that should be equal to 0. You're adding 3 moments, then minusing the anti-clockwise, and this is how the formula will look. The 3 moments, and they will be equal to the 1 anti-clockwise moment. And then once you add all the moments, you are going to divide it by the distance of R2 from the pivot point, and the answer will be 12.58 kilonewtons, and that is R2. In order to solve for R1, you're going to add all the moments, or all the downward forces rather, and you will arrive at an answer of 21 kilonewtons. Then all you are going to do is minus 12.58 from the total downward forces in order to get R1, and the R1 will be 8.42. So that's how you deal with UDL loads, or uniformly distributed loads, when solving for reaction forces R1 and R2 in a simply supported beam. I hope this lesson was informative, and I hope you grasped the concept. Please like this video, share this video for others to see, and subscribe to the page for further content. Have a good day.